Hello everyone, welcome to JCE Connect. Today we'll be discussing on highway construction, earthwork, filling or embankment and cutting. Here in this diagram you are seeing the bottom line, which is, you'll assume it has natural ground, and trapezoidal portion of filling is embankment. This embankment is very important in case of high flood level. HFL is near the ground, or the highest water table is towards the surface. Any major water bodies are nearby, then we cannot construct the highway uh, at the ground level. Then there is a need for highway embankment. Once the alignment is finalized and set out for construction of new highway, the subsequent stages, like design of geometric features, choice of pavement types, investigation of locally available soil or construction materials, their cost, labor cost, then the different tests on the available materials, drainage conditions, structural designs of pavement, cross drainages will be done. So highway construction consists of mainly the earthwork. It's by volume it is very large quantity, because along the alignment in your extensive survey also you have experienced, or in day-to-day life, when you are using a road to move from one origin to other destination, from home to college, from home to office, or any journey you have observed, it is not a flat terrain. It is up and down movement is there. So that is with respect to the natural ground profile. In some sections we have to go along with the natural ground profile, and some portions, especially when we come across expressways or national highways, especially in golden quarterlet projects, you have observed a lot of cutting and filling is being done. The reason behind that, there the priorities with respect to the comfort of the rider, design speed is need to be maintained to reduce number of accidents, to provide less number of horizontal and vertical curves. So then there will be uh, a need to fill or provide an embankment. When you are taking the highway at same level, then the natural ground profile, it is not same along your alignment. So there is a need to fill the soil material, means artificially we are lifting the natural ground profile to our form formation level, right? So it need to be strong as strong as natural ground. So earthwork includes construction of embankment using locally available soil, excavation for road stretches, in cutting and grading and adequate compaction of bottom surface, excavation of earth, also done by providing a longitudinal road side drains. Here in the diagram you can see both the sides, uh, side drains we have provided, right? And filling of the central earth fill. So for this embankment, we'll be using locally available soil, and you cannot use any soil, so that need to be tested and it should fulfill the requirements. So that we'll be discussing in the later part. A highway embankment is designed and constructed such that the formation level is above the ground level and also sustainable in case of high flood conditions, or it should be uh, above the highest water table, so that it should not affect the pavement structure, that is base, sub base and wearing course should not get affected, that because that is one of the costliest construction activity, and that affects the movement of vehicles, right? So there are main the components, if we see, that is embankment, subgrade, drainage layer, shoulder and pavement layers. Apart from these five layers, we need to provide the side drains and other specific drains, such as capillary cutoff need to be done, right, so that it should not affect the upper layers. When the original ground is flat without cross drainages, two longitudinal side drains are provided, as we see in this same uh, figure. Both sides we are providing the side drains, and if the original ground has cross slope, means natural profile is that is hill terrain if you are taking, so only one side longitudinal side drain we are providing, that is towards the hill, and towards the downhill there is no need to provide the side drainage. The embankment is generally constructed using that is good quality of soil or muram, and maximum size of the aggregate or muram or construction material which will be using as a subgrade is 75 mm. The material considered is soil, muram, gravel, or mixture of these which are free from organic matter, stems, root, or any organic ingredients which will should not affect. And before construction, that entire natural ground need to be cleaned properly. There should not be any small water bodies or pockets, weak pockets, right, that need to be stabilized. The essential requirement of soil properties considered suitable for highway embankment as per IRC is it's a liquid limit to be less than 70%, plasticity index should be less than 45, and free swell index should be less than 50%, and maximum uh, laboratory dry density on compaction, especially heavy compaction or modified Proctor test, it should not be less than 152 kg per meter cube, right, for a embankment height up to 3 meters, and 160 kg per meter cube for embankment height more than 3 meters. After cleaning the site, mark the limits of embankment by fixing the pegs. Here you can see. So you need to fix the pegs, or wooden pegs are fixed, or I can use uh, white chalk for marking. White can use those things. And the embankment shall be built suitably wider than the specified formation width, so that surplus material at edges may be trimmed to ensure proper compaction of the edges and side slopes. Right here you can see these side slopes of the embankment can be trimmed later with the required slope, so that to achieve the better compaction. And the each layer is compacted by using rollers, and compacted at the OMC optimum moisture content. The embankment is constructed by spreading the loose soil and maintaining the OMC. We are compacting it. The compacted thickness of each layer generally varies from 100 to 300 depending on the several factors such as compacting equipments use, what is the type of the soil density to be achieved, and any other specifications that particular it is mentioned, because uh, whether you're doing it for state highway, national highway, other district road, village road, right? So respectively it varies. Minimum of 97% of dry density need to be achieved as per IRC and Indian Road Congress and the Ministry of Road Transport and Highways, that is MORTH. The specifications are given, and also by the Bureau of Indian Standards. Heavy compaction, modified compaction density is considered. Uh, After spreading the loose soil, it is compacted to the maintaining the OMC. If in some times you will observe the procured soil is more wet than the it is required. The moisture content in the soil is more than it is required. So that time you need to spread and allow it to dry. Wait for some time after evaporation of water from the soil. Then you can check the moisture and compact it to the required density. After ensuring that the layer has been compacted to the desired density, the next layer of soil is spread over the largely compacted layer, and if less water content is there, water need to be added, that is OMC need to be added, mixed thoroughly. It's not happen that it is only certain portion moisture content is high, certain portion it is completely dry. It need to be with the help of spreaders, various construction equipments, it need to be mixed thoroughly, then it need to be compacted, and the process is repeated until the desired height of embankment is achieved, right? And in some specifications, it is also allowed to use the industrial wastes. Most commonly used industrial waste is fly ash, which fulfills the properties as per the IRC guidelines and may also be used for the construction of highway embankment. You might be aware that National Highway, the Golden Quadrilateral Project, East-West corridors, and this port connectivity highways, they have specified that use of industrial waste is mandatory, and because of this many of the contractors have used these fly ash and other industrial wastes mm, in the construction of the highway embankment. And there are various methods of constructing embankment making use of this fly ash when the material is available in abundance as the waste product within the reasonable distance. For example, Delhi, Badarpur thermal power plant. From that, they have used for this NH2 from Delhi to Agra. That particular stretch they have used. So similarly, in if it is locally available, then your transportation cost is less because the quantity of material, waste material or any material which you want to use it for embankment or filling, that quantity is large, not as the bituminous layer which is of lesser thickness. So quantity required for embankment is much larger, so transportation cost will be higher. That's why we need to select locally available either maybe waste material or suitable construction material, which will reduce the overall cost of the project, right? So we were discussing this fly ash. There are various methods. So one of the effective method is by sandwiching fly ash layer of thickness 1 to 3 meters between the intermediate horizontal layer of thickness about 0.5 meters, right? So, or it may be mixing with the soil, and so the sandwiching method is most effectively practiced method. So we'll just revise on the embankment with respect to functions to keep the subgrade or the upper layers of the pavement above the highest water level or the high flood level. There is a need for embankment, and to prevent the damage to the pavement due to surface water from the adjoining lands, there is a need for embankment. To reduce the possible damage to pavement layer due to capillary rise, capillary water, there is a need for an embankment. To maintain the design standards of highway with respect to the vertical alignment, there is a need for an embankment. Or to have a leveled ground even in the low lying areas to maintain the alignment, there is a need for embankment. Then we have discussed different materials used as a construction embankment materials, that is muram, then waste material as fly ash, right, and soil gravel, and maximum size of the coarse material or stone aggregates which will be using as a construction embankment or fill is 75 mm, and as per IRC specifications, liquid limit should be less than 70, plasticity index less than 45, free swell index less than 50%, and maximum dry density MDD should be 152 kg per meter cube for embankment height up to 3 meters, and 160 kg per meter cube if the embankment height is more than 3 meters. And we will be avoiding that is peat, marshy soil, or swampy soil, that is loose, weak soils. And later we have discussed that is the construction steps, that is the area need to be cleaned with a free from vegetation or organic substances, then that need to be compacted, then we'll be dumping the good quality of soil, muram, or construction embankment material, then that need to be compacted with our desired OMC, that is compacted in layers. Then the edges are marked, then whatever slopes which you will be providing, that is also trimmed. And if the embankment height is more, then the steep slopes should be avoided, so that future failure should not occur, and it should need to be compacted to a 95% of the density. And we have discussed that is the important elements with respect to embankment is its height, fill material, the settlement, stability of foundation, and the stability of slope. Stability of slope is very important, as the height increases. If the height increases, then the slope, whether in the slopes, finite and infinite slopes, so its suitable slope need to be provided. So because in adverse climatic conditions, that should not fail, and proper drainage should be provided. And if the embankment need to be done on existing pavement, then there is a need to scratch and completely remove the existing pavement surface, flexible or it may be a rigid pavement. You might have observed in the national highway this golden quadrilateral project, some of the portions, it is almost of more than 15 years. The project has been completed, and some of the stretches, for example, if you are coming from Bangalore towards Belgaum, the Haveri stretch, wherever bypass, some of the vehicle underpasses they are constructing for that, already existing road is there, hmm, at the ground level, but now they want to construct the flyover. So existing road need to be uh, removed, so they are completely scratching it and removing the pavement surface, and that, so that the bonding between the filling material should occur properly. Right, most of the bypasses, and bypasses you'll observe they are going it for vehicle underpass. Earlier it was a cattle underpass, a smaller, or there is no vehicle underpass. If they to construct that vehicle underpass, the existing road were completely removed, and a bridge is constructed, and there you will observe such kind of activities. Right, the for embankment less than 1 meter above the natural ground, the ground surface should be loosened up to a minimum depth of 150 mm. So here you can see. So all these steps we had discussed, that is compaction of soil, should be done at OAMC with a tolerance of plus or minus 2%. Each layer should be compacted at 97% of standard Proctor density. For modified Proctor density, if you are going for national highways, expressways, ensure longitudinal and cross profile should be in the conformity with the approved drawings. So drawings will be getting it from the office. So as per that you need to execute on site. Approval of engineer should be obtained for each finishing layer. Subsequent layer should be placed only after the finishing layer has been tested and accepted by engineer. When an existing embankment or a subgrade is to be widened, for example, this uh, Belgaum to Hubli, or many of the stretches where traffic density is very high, increased over a period, National Highway had called for tenders to increase from 4 lane to 6 lane. So existing 4 lane road is there, and that is provided with a certain embankment. So existing embankment is there. So on that, if you are if you want to widen, then you need to scratch it, and for widening you need to provide a slope. uh, the subgrade is to be widened, then, and its slope are steeper than 1 vertical to 4 horizontal continuous horizontal benches, each at 300 mm wide, should cut into the old slope. Right, so this clearly you can understand, especially in the construction of our dams, because in very selected stretches you'll come across uh, highway embankments, because most of the time we try to avoid um, higher embankment fills for the safety reason and to avoid the heavy construction costs. Right, next is earthwork and cutting. Right, so after the site clearance, the limit of excavation should be set out true to lines, curves, slopes, grades, and cross section as shown on the drawings by constructing a reference pillar, back cutting lines, reference lines. In your extensive survey project also you had seen some of the portions we need to cut. You have taken the existing ground profiles, right, and where the natural ground height is more than the the leveled alignment, right. So that time we need to cut the existing ground, and to it may be, if it is of good quality, that same cut material can be used as a filling material for the same highway construction, right. And for the smooth flow of vehicles, so to avoid steep up, need to go for the cutting. And this cutting is required to reach the destination in a short distance. Otherwise you need to take a complete round of the entire hill, right. So with respect to different types of routes, it varies. For example, if you are going for expressway, national highway, then instead of cutting the entire uh, hill, they'll drill a tunnel. As the project cost funding is more, they can afford tunneling in the hill or the ground, and they'll provide a passage and reduce the total instead the round. If it is taking 2 to 3 kilometers, within 4 to 500 meters of tunnel they will cover, and overall maintenance and its vehicle operation cost is less, right. So that is one of the methods. If you are going for say ODRs, other district roads, or state highways or MDRs, then instead of tunnels we'll be going for we'll climb up to certain height of the hill, then we'll provide small portion of cuttings, right, on both the sides to the required width of two lane. For example, up to 9 to 10 meters of width, or 15 meters of width of cutting is done, and we'll be providing the road, right. If it is of village road, then the cutting height is most of the time you have observed that is not very steep, or higher cut won't be there. That is minimum of 3 to 5 meters of cutting most of the time. That's why in a village roads, or less important, less volume roads, you'll observe uh, n number of horizontal and vertical curves. To avoid the vertical curves, we are going for cutting and filling, right. So this filling is so we'll see the cut formation which will serve as subgrade. That is as we are cutting the surface of the natural ground, then the lowermost layer can act as a subgrade if it is of good uh, quality of soil, or if it is a hard rock. Most of the time we try to avoid lesser depth cutting of rocks. By blasting and other things you can do it, but it is the cost will be higher. It should be checked for its density. The field density of material in the top 300 portion is less than 100% of maximum proctor density, and will be the formation material should be loosened to a depth of 500 and compacted to the 100% standard proctor density. In hill areas, the cutting should be done from top to bottom. Special attention should be paid to side slopes and side drainages in cutting. Yes, in some of the portions, even in national highways
lot of between Pune to Mumbai. If you observe, that is uh, for construction of that expressway, they have some steep cuts they have made in the hill, Lonavala hill. That maintenance of those slopes is also very important, because that will affect the operation of uh, highway, vehicular operation on highway. Rock, when encountered in road excavation, shall be removed up to the formation level. Where unstable shales or other unsuitable material are encountered at formation level, then that is extracted up to 500 below the formation level and recompacted. So overall, here the quantity of cutting and quantity of filling for the selected stretches uh, should be nearly equal, so that we can use the cut earthen material in the as a filling material, as an embankment, so it will reduce your cost. And the cutting portion, the side slopes need to be taken care. The steep cutting should not be, higher depth of cutting should be avoided. So thank you very much.